Today we are working on writing function rules. So we are continuing our work with functions as well as building the rules from the functions. So when we are talking about a function rule shows how the variables are related. So when we're talking about our variables, we're referring to our input and our output values. So a question to ask yourself is, what am I doing to x to get y? So remembering that our x value is our input value and the y is our output value. So we're going to start by working with both of these situations. So a lot of times you'll see a function machine, and so what this means is we have our input coming in, which in this case is 3. We are given our function rule, which is 2x plus 1, and so we are going to be looking for our output value. So we can write this as a function. So we could write this as f of x equals 2x plus 1, because that's our function rule. And so if we are evaluating this with our input value of 3, remember our input is our x and our output is our f of x or our y value. So if we are going to plug in 3, so we would have f of 3, and then we would plug in 3 for x. So 2 times 3 plus 1. So f of 3 is 2 times 3 is 6 plus 1. So f of 3 is 7. So our output value in this case is 7. So that is if we are given our function rule and also our input. So now we're going to look at one where we are given our function rule and we are given our output. So we are looking for our input. So we could write this function as f of x equals negative 3x plus 1, because our function rule is right here. So now we are given this value of negative 11 for our entire y value, or that f of x. So we are looking to find what our input or our x value is. So in this case, we would have negative 11 equals negative 3x plus 1. And so then we would just solve this equation for x. So we would subtract 1 from both sides of the equation. And we would get negative 12 equals negative 3x. And we would divide both sides by negative 3. So our x value in this case would be a positive 4. So that means that our input value with this function would be 4 if our output is negative 11. So what we're working on today is building this function. So we are going to be given our input values and our output values, and we're trying to find out what happens within this function machine to come up with those values and that rule to make this statement true. So what I want you to be doing while we're working these out together is I'm going to give you piece by piece input and output values. And so what I want you to do then is to think of a rule that would make the statement true. So what may hold true in the beginning may not end up holding true as you continue on, but the function rule has to work with any input values we put in. So you may have to revise your function rule as we progress. So in this case, we are given our input of 6 and an output value of 12. So I want you to jot down a possible function rule given the input of 6 and the output of 12. And so as I give you more input and output values, I want you to see if it's true and or revise it if necessary. So if I were to give you the input value of 5 and the output value of 11, so let's put 11 here, does your function rule still hold true with both of the input-output pairs that we have? And if it does, then hang on to that idea and let's see if it works for this third set. If not, then I want you to revise it and see what else you can come up with so that the rule would fit both situations. So let me give you another input-output. So we have an input of 10, and if I were to give you an output value of 16. So when our input is 10, our output is 16. So if you need to make revisions to your function rule, do so now. And I'm going to give you one more set of values. So if I were to give you an input of 20, and if our input is 20, our output is 26. So hopefully you have found a rule that would work for all of these ordered pairs. And so the function rule you should have come up with is x plus 6. So for each of our x values, if you plug that into this function rule, you would get the appropriate output. So our function rule is x plus 6. So it has to work in each of the situations. So if we were to write this as a function, this would be f of x equals x plus 6. And this would be our function. So let's try another. So if I have an input value of 5 and an output of 13, I want you to see if you can come up with a function rule that would work with this relationship. And feel free to pause at any time if you need a few more seconds or a minute to come up with a function rule. So if I were to give you an input of 10, and if I were to say that the output is 23. So once again, check your function rule that you already came up with, make revisions if necessary, and pause the video if needed. If I were to give you an input of 1 and an output of 5. Okay, I'm going to give you a couple more pairs. This one can be a little, there's a few steps involved in this one. So if I give you an input of 12 and an output of 27. And if I give you an input of 0 and an output of 3. So I want you to pause the video until you have come up with a rule that would work with all of these input and output values. Okay, so let's see if you were correct. So you should have come up with the function rule of 2x plus 3. So if you were to plug in 5 for x, so 2 times 5 is 10, plus 3 would give you 13. 2 times 10 is 20, plus 3 gives us an output of 23. 2 times 1 is 2, plus 3 is 5. 2 times 12 is 24, plus 3 would give us an output of 27. 2 times 0 is 0, plus 3 would give us an output of 3. So our function rule for this would be f of x equals 2x plus 3. So what we're going to do next is, given some input-output tables, I want you to come up with some function rules or functions that would work with those input-output values. So there are 4 on the back side of your notes sheet that I want you to come up with a function rule for those ordered pairs. And then when you are ready to check your work, push play on the video and I'll reveal the answers. Okay, so given the first set of input and output values, so we have the ordered pairs 1, 2, 4, 8, -16, -32, and 0, 0. So hopefully you took a moment to come up with a function rule between the relationship between the input and the output. And so in this case, you could have had 2 different scenarios. So you could have had f of x equals x plus x or f of x equals 2x. Both of those would have worked. So if you were to plug those values in, and I do want you to fill this in on your notes, so make sure that you do so. So if you have, and you can plug it into whichever function you wrote. So if you have f of 1, then that would equal 2 times 1, so f of 1 would give you 2. So f of 4 would be the same as 2 times 4, so f of 4 would give you a value of 8. If we were to plug in -16 for x, so we would have f of -16 equals 2 times -16. So our f of -16 would give us -32. If we were to plug in our input of 0, so f of 0 equals 2 times 0, so f of 0 equals 0. So let's look at the next one. So if we have our input of 1 and our output of -1, our input of 2, output of 0, input of 3, output of 1, input of 4, output of 2. So in this case, our function rule, we could write our function of f of x equals x minus 2. So if we were to plug in our values into our function, so remember our x goes into our x values, so f of 1 equals 1 minus 2. And when we simplify that, f of 1 equals -1. If we were to plug in 2, so f of 2 equals 2 minus 2, so f of 2 equals 0. F of 3 equals 3 minus 2, so f of 3 equals 1. And lastly on this one, so f of 4 equals 4 minus 2, so then f of 4 is 2. So let's look at the bottom two. So given our input and output values, so if we have an input of 1 and our output is 1, an input of -2 with an output of 4, an input of 3 and an output of 9, an input of -4 and an output of 16. So our function rule, or our function, is f of x equals x squared. So when we plug in our values, let's see what this looks like. So we would have f of 1 equals 1 squared, and 1 squared is 1, so f of 1 equals 1. If we plug in -2 for x, or our input, f of -2 equals -2 squared. And remember that -2 squared is -2 times -2, which would give you a +4. So f of 3 equals 3 squared, and 3 squared is 9, so our output value is 9. Our input of -4, so f of -4 is the same as -4 times -4, which would give us a +16 as our output. Last one, so if we have our input of 3, our output of 7, input 8, output 22, input -1, output -5, and input -3, output -11. So this one has 2 steps involved, so our function is f of x equals 3x minus 2. So if we were to plug these values in, so f of 3 equals 3 times 3 minus 2. 3 times 3 is 9, minus 2 would give us an output of 7. If we plug in 8, so f of 8 equals 3 times 8 minus 2. So f of 8 equals 3 times 8 is 24, minus 2 is 22. F of negative 1 equals 3 times negative 1 minus 2. So 3 times 1 is negative 3, minus 2 would give us an output of negative 5. And lastly, f of negative 3, so negative 3 times negative 3 minus 2. Negative 3 times negative 3 is negative 9. Minus 2 would give us an output of negative 11. So hopefully you have made corrections to your note sheet if necessary. And also I hope that you got some of those function rules correct as well. So we are going to continue by writing a function based on a real-world scenario. So in this example, it says Ethan has a job mowing lawns in his neighborhood. He works up to 12 hours per week and gets paid $10 per hour. So we are needing to identify what the independent variable is, the dependent variable, and then we're going to write a function and evaluate the function given a value. So recall that our independent variable is the value that we can control or we can change. And so our dependent is what changes based on our independent variable. So in this case, the independent variable is the hours that he works. And our dependent variable would be our pay or the income that he has. So remember that our independent variable is our x value and our dependent variable is our y value or our f of x. So if we are writing a function based on this situation, so it says that he works up to 12 hours per week and gets paid $10 per hour. So if our pay is our f of x, our pay is equal to however many hours he worked and the amount that he gets paid per hour. So if he gets paid $10 per hour, we can write this as f of x equals 10x. So if we want to use the function to calculate how much money Ethan would earn if he mowed for 8 hours this week, then we could plug that value in and find f of 8. So if we had our function of f of x equals 10x, and we want to evaluate that for f of 8, and we would plug in 8 for x, so 10 times 8. So f of 8 would equal 80. So he would earn $80 for 8 hours worked. So then the last part asks, what are reasonable values for the domain? So if we go back and recognize that our domain is our independent variable, so remember our x values are the domain, and that's our hours worked. Well, it gives us some restrictions about how much he works, and so it tells us that he works up to 12 hours per week. So we know that that's the maximum value that he's going to work is up to 12 hours a week. So our domain then can be 0 hours. He may not work at all, so 0 hours up to 12. So our domain could be 0 to 12, and anywhere in the middle would work as well. And so then if we are looking for what are the reasonable values for the range, so recalling that the range is our dependent variable or our y, and that's referring to the pay that we have. So now we need to consider, well, if he were to work for 0 hours, how much money would he make? Well, he would make $0 if he doesn't work at all. And so if the maximum that he is going to work is 12 hours, what's the maximum of the range values that we could encounter? And so if he makes $10 an hour and the max is 12 hours, then the largest range value that we could see would be 120. So it is really important that we think about what would be reasonable. And in this case, we have some restrictions on what our domain and our range would be as far as reasonable values for the amount that he's going to work per week. All right, so now you are ready for your assignment over writing function rules. So make sure you pick that up and get started on that.